This is the introduction of this video. One of the applications of differentiation in calculus is related rates. Related rates problem using application of differentiation, therefore it is strengthen the knowledge of calculus. Related rates basically is about finding rate of change of a quantity by relating it to other quantity that already know the rate of change of it. Related rates application in life, for example, like a balloon being filled with air. The radius of the balloon increases as well as the volume increase, which is these two related quantities are changing. We can find the changing radius if we know the rate of change of the volume and time.
Problem statement. Related rates cone problem. A water storage tank is an inverted circular cone with a base radius of 2 meters and a height of 4 meters. The radius is constantly half of its height. If water is being pumped into the tank at a rate of 2 meter cube per minute, find the rate at which the water level rises when water is 3 meters deep. So from this question, we can know the keyword is radius is constantly half of its height. Radius is constantly half of its height. So we got R equals to 1 over 2h. And secondly, that you have to know to solve this problem is the keyword of rate. So when the question say rate, it is a reference to say per dt. Per dt.
The objective of this problem solving is to find the rate of water level increases after the tank being pumped with an amount of water. Secondly, to apply Cohn's volume formula to find initial water level and final water level after it differentiates.
To solving this question, first, we must identify the equation to use. Second, determine the equation to use. Third, coordinate solving problem by using differentiation. And lastly, use the chain equation to get the final answer. To solve the question, first, we must identify the information that are given in the question. Usually, there are some information that already given in the question. So it is important to read the question briefly and carefully to make sure we don't miss any information. So we can see here, first, we list out what the information that are given inside the question. From the question, we get the value of dV over dt, which is 2 meter cubic. Next, we understand the question asks to find the value of dH over dt when the height h equal to 3.
This is step 2. Determine the equation to use. We use equation Cohn's volume formula, which is V equal to 1 over 3 pi r square h. As we know, radius is constantly half of the height, which is height is 4. So r over h equal to 2 over 4. Then we simplify it into r equal to h over 2. And we substitute the r into the equation, the Cohn's volume equation. Then we can get V equal to 1 over 3 pi h cube over 4.
Step 3. Left side is V, right side is H. So we got dV over dH. We can also determine what to differentiate by looking at the first step. We have dV over dt and dH over dt. So logically, what to differentiate will be dV over dH or maybe dH over dV. But this depends on equation. The point is, it will not be more than 3 variables for this kind of question, just V, H and T. So based on that, there is no dH over dr or dV over dr. No. Then don't forget to substitute 3 that come from equation after differentiate to get the answer. Subs 3 in H. This leaves the answer in term of pi. Last but not least, step 4, chain rule. So where did this idea come from? So let me explain. Actually, any kind of fraction, we can separate it. So dH over dt, which is what we want to find, we can separate it like this. dH over something times something over dt. At the something place, if we put the same thing, the answer will also get dH over dt again. So we choose to put dV that can be related to solve the problem. And that's why we got dH over dt equals to dH over dV times dV over dt. And after that, we substitute the answer. But is it we have dH over dV? No, we just have dV over dH. So what to do? Turn it upside down. So from 9 pi over 4, we got 4 over 9 pi. Times by 2, and we got 8 over 9 pi. And this will be your final answer.
In conclusion, the rate of water level is rises in the cone is 8 over 9 pi meter cubic per minute. We can apply differentiation concept and relate it with cone's volume formula to get the rate of change of the volume. Then, using chain rule to get the water level rises. So, that's all from us. Thank you.